In Notability, I'm going to go to our Unit 2 notes, which we did in our last class. That's where we did the complex numbers, the stuff we just did our class kick on, and our notes were in that. So the next section is solving quadratics. And so we're going to be solving quadratics a few different ways. First, we're going to do it by factoring, okay? And these can all be done multiple ways. Some ways are more advantageous than others, depending on the type of problem that you're doing. And sometimes it takes a little bit of practice to figure out which is the best method to use. So for right now, I'm just going to tell you that we're going to solve these by factoring. So for the first one, we want to solve this for factoring. So the first thing I have to do is I have to factor the left side. And the first step in factoring is always to factor out a GCF. So that factors into x times x minus 5. Now using the zero product property, that means I set this equal to 0 and I set this equal to 0, because if either one of them is 0, then 0 times the other one will of course be 0. So that means that using this, x equals 0, and using this, x equals 5. So I get two answers. X is 0 and 5. And you can always test those by plugging them back in for x to see if they work. All right, we'll solve the next one here by factoring as well. Now to do that, I need to get everything on one side. So I'm going to move the 20 over. So we got x squared minus 8x minus 20 is equal to 0. So now I have a regular trinomial. I need to factor this guy on the left side. First two things will be x and x to give me x squared, of course. I need factors of 20, which could be 1 and 20, 2 and 10, 4 and 5. But I have to get 8 from them. So I think 2 and 10 is the way to go. And I want it to be minus 10 and positive 2, because that gives me negative 8x in the middle and negative 20 in the end, by the way. So now it's factored and set up for the zero product property. So x equals negative 2 from here and positive 10 from here.
Wait, I forgot. I'm not sure. I'm just, I think, I'm not sure. I'm just remembering. But isn't it that you can't use a negative, right? Can you?
You can. I think what maybe you're thinking of, Vince, is perhaps a radical equation if you had a square root.
Maybe. I don't know. I remember like we used to always use the positive number or something.
Yeah, in this case, you can use a negative. So I think you're mixing it with a different concept.
Okay, thank you.
Yep.
I also have another question for
Yeah.
the same problem.
Yeah.
Would the negative 2 become would it if we plugged it in, right? Would it be a positive 4 or a negative 4? Because don't you need parentheses in order for it to become a positive?
You do, and it should be in parentheses. So this is a good question. If you plug negative 2 in for x here, that's going to be negative 2 in parentheses squared minus 8 times negative 2.
Okay.
And so this is 4, positive 4, and this is positive 16, which gives you 20. So when you're plugging things in, you always want to plug them in using parentheses.
Okay, thank you.
Yeah. Any other questions? These are good. All right, for part C, it's a little more challenging because when we get everything on one side, and I'm going to move it all to the left, although you can move it either way, but I think it's easiest to keep the leading coefficient positive. This one's a little bit more challenging because we have to factor something where the leading coefficient is not 1. Well, what the heck? We're honor students. We can do this, right? So let's see. We have 2x and x. And I want factors of 14. But those factors don't have to give me 11 because whatever I put here is going to be multiplied by 2. So for example, if I did 2 and 7, that's going to be 14x and 2x, which doesn't give me 11, so that's not my answer. But just remember that that thing on the outside is multiplied by 2. So I switched them. So this, I'm just using a trial and error. On the outside, I have 4x, and on the inside, I have 7x, which does give me 11x if they're both positive. So there are my two factors. So on the left side, I get x equals negative 7/2, because negative 7/2 would make that equal to 0, and negative 2. Because negative 2 would make that equal to 0. All right, so those are quadratics that we solved by factoring. Some quadratics you can solve by just taking a square root. And the difference is, like in this problem, it looks like the ones we just did, but there's no x to the first power term. So in that case, it's easiest to solve by just taking a square root and getting the variable by itself. So let's start with part A, for example. If I wanted to solve this, just divide both sides by 3. So I have x squared equals 9, and take the square root of both sides. So the square root of x squared is x. The square root of 9 is 3. But do not forget this one very big thing, that x is either plus or minus 3. When we took the square root of this term, we get plus or minus. Okay, so we actually have two answers. X is positive 3 and x is negative 3. This is just a lazy person's way of writing it. You write plus or minus. That means two different terms, two different answers. All right, part B is similar, but we got to get the x squared by itself first. So I'll move the 8 over. So I have negative 2x squared is equal to 16. Divide by the negative 2. Take the square root of both sides, so x equals plus or minus the square root of negative 8, which is not a real number. But remember, we now know something about complex numbers, right? We can do something like this by splitting it up into the square root of 2 times the square root of 4 times the square root of negative 1, and do our factor tree. So we get 2 root 2i. And so our answer, as ugly as it looks, is that x is equal to plus or minus 2 root 2i. So there are two answers, 2 root 2i and negative 2 root 2i.
Is the I always outside of the square root?
Yes, it is in this case because the square root of negative 1 is the I on the outside. So good question. You definitely have to write it on the outside.
Do we need to write both types of the answers?
When you say both, do you mean this and this?
Yeah.
Not necessarily. I mean, you could skip from here to here.
Okay.
Yeah, you don't have to write both types of answer, I guess, is the easy way to answer your question. Most students have difficulty going from here to here in their head, but if you can do that, not a problem. All right, let's do part C. And this one is a little different because we still have just a squared term. So I'm going to get that part by itself first by subtracting 4 over So I have 3 times quantity x minus 2 squared is equal to 75. And divide by 3. So we have x minus 2 squared is equal to 25. All right, now I'm going to take the square roots of both sides. Well, when I take the square to the left side, I get x minus 2. When I take the square to the right side, I get plus or minus 5. So I'm going to write out 2 equations here because we have x minus 2 equals negative 5 and x minus 2 equals positive 5. And so I get my 2 answers from those things. So x comes out to be negative 3 or positive 7. All right, we have one more method. Are any questions before I go on to the next method? All right, so now we're going to do by quadratic formula. So that is the quadratic formula. We talked about this a little in our last class. A is the leading coefficient. Like in this case, our A is 1, our B is 6, and our C is negative 5. So I'm plugging those into the quadratic formula. So x equals the opposite of 6. So that's the opposite of B. Plus or minus the square root of B squared. So that's 36 because that's 6 squared. Minus 4 times 1 times negative 5. And that's all over 2 times 1. So now it's just arithmetic, but sometimes it gets a little shaky. That number that's underneath the square root, that's a really important number. Because if it's negative, then I have that complex number. And if it's positive, then I just leave it and I have to reduce that. So negative 4 times negative 5, that's going to be 20, and 36 plus 20 is going to be 56. So I have the square root of 56 over 2. So I need to do a factor tree. So for 56, for the square root of 56, let me do that over here. 2 and 28, and let's see, that's going to be 2 and 14, and that's 2 and 7. So I get 2 root 14. I know I did that kind of quickly because we've done those before, but if you'd like me to go over that slower, please let me know. Yeah. So I'm gonna do that again, okay? So for the square root of 56, I know that 56 is even, so I can split that. Half of 56 is 28. And I want to get it down to all prime numbers. So 2 is a prime number, but 28 is even, so I'll split that into 2 and 14. And then 14, I'll split into 2 and 7. And now I have all prime numbers. So once you have a factor tree of all prime numbers, you look for pairs. I have a pair here. The pairs go on the outside. So that gave me 2. And anything that's not paired up has to stay inside. So 2 times 7, that gave me the square root of 14.
Can't we reduce the -6, positive or
can.
negative?
Yep, we're not, yes, you're exactly right. We're not done yet because now we can reduce these because 2 goes into all of them. So we cancel a 2 from there, and from there. Not from the 14 though, because this is all one term. And so our answer is that x equals -3 plus or minus the square root of 14. All right, I'm going to do C because I think that's a harder one. Because I'm only going to do one more, and then we'll do B in our next class. So I'm going to do C. I'm going to get everything on one side. So I'll write that as 2x squared plus 11x plus 14 is equal to 0. And then I'm using the quadratic formula. So x equals the opposite of 11 plus or minus the square root of 11 squared, which is 121, minus 4 times 2 times 14, that's 4ac, then all over 2 times a, which is 4. So x equals -11 plus or minus the square root of, let's see, we have 4 times 14, 56 and 2 would be 112. So 121 minus 112. I do that right, guys? Come on, help me out, you math wizards out there. I'm doing this in my head here.
I'm pretty sure. I think you did it right.
Thank you. So -11 plus or minus the square root of 9 over 4. 9, of course, is a perfect square. So -11 plus or minus 3 over 4. But
So
those,
if it's a sorry.
yeah, if it's a perfect square, we actually can keep going with this and find out what that number is. -11 plus 3 is -8 over 4, which is -2. And -11 minus 3 is -14 over 4, which is -7/2. So remember when I said that this number under the square root was really important? Because if it comes out to be a positive number, then we get this thing where we can maybe reduce the radical. If it comes out to be a perfect square, we then get nice numbers for our answers. And if it comes out to be a negative, then we're going to get imaginary solutions. So we would get something that looks like this. And now remember that these problems can be solved multiple ways. In fact, this problem right here, with our answers of -2 and -7, that's this problem right here. We had already done that and solved it by factoring and got the same answers using the quadratic formula. All right, any questions before we go to homework?
So why would we choose to do one method over the other?
Yeah, great question. They both have different advantages. Factoring is faster. Like this problem took a heck of a lot longer than this problem. So factoring is faster, so it has that advantage. The disadvantage of factoring is that not all of them factor. This one, we cannot solve by factoring. So the advantage of the quadratic formula is that it always works. So here's my suggestion. Always try and solve by factoring if you can, but don't spend too much time doing it. Try and factor for 20 seconds. If you can't factor it in 20 seconds, drop it, use the quadratic formula. But both will work. Assuming it can be factored, you'll get the same answers.
On like a test or quiz, but won't you tell us like use this by like factoring or quadratic, or do we just pick?
Probably would have both. I might have one question say solve by factoring, one that says solve by quadratic formula, and then I might have like 5 of them and say do it however you want.
Oh, okay.
All right, anything else, guys?